awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih. Hai, Assalamualaikum. Jom kita revise sambil berehat. Sambil berehat pun, kita boleh belajar tahu dengan tengok handphone. Apa tunggu lagi? Jom kita mula. Hey, tahukah anda setiap objek yang mempunyai jisim iaitu mass dan bergerak ataupun move with velocity v mempunyai momentum. Apakah momentum? Okey, sekarang cuba kita tengok contoh ini sekiranya awak ada abang yang naik basikal and it's moving to the right with a velocity of 0.2 meter per second dan awak berdiri di hujung jalan dan cuba untuk berhentikan abang awak. Hebat ya? Akhirnya, awak berjaya memberhentikan abang awak itu. Tetapi, jika abang awak memandu sebuah kereta and move to the right with the same velocity of 0.2 meter per second, kenapa awak takut untuk cuba memberhentikan kereta tersebut? Basikal boleh berhentikan, tetapi bukan kereta tersebut. Tapi kenapa? Okey. Jom kita lihat perbandingan antara mass of the car and the mass of the bicycle, where the mass of car is bigger than mass of the bicycle. Based on the momentum equation, where momentum is the product of mass and velocity, therefore, based on this equation, we can see that momentum depends on the mass of the object. Okay? Jadi, apabila mass of the car is bigger than mass of the bicycle, jadi kereta mempunyai momentum yang lebih besar daripada momentum basikal. Lagi besar mass sesuatu objek, lebih besar momentum yang dimiliki oleh objek tersebut. Oleh itu, lebih susah untuk awak berhentikan sebuah kereta berbanding sebuah basikal. Okey, sekarang kita cuba tengok satu lagi contoh di mana kita ada seorang student A dan kita ada student B, di mana kedua-dua pelajar ini akan baling sebiji bola with the same mass which is m equal to 0.2 kg to the right dan velocity of the ball from student A is 5 meter per second, where velocity from the second student B is 1 meter per second. Kita nampak ya perbezaan velocity dari kedua-dua pelajar tersebut. Jadi, jika awak ingin tangkap bola ini, bola dari student manakah yang lebih mudah untuk ditangkap? Semestinya student B. Okey? Tapi kenapa? Alright, let's compare the velocity of the ball, where the velocity of the ball from student A is bigger than velocity of the ball from student B. Therefore, since momentum is depends on the velocity of the object, so kita boleh kata momentum bola daripada student A lebih besar daripada momentum bola dari student B. Sebab itu, lebih mudah untuk awak tangkap bola daripada student B kerana momentum bola daripada student B lebih kecil. So, lagi besar velocity of the object means that lagi besar momentum yang dimiliki oleh objek tersebut. So, that's all the revision about momentum. Lihat sini, kita ada sebuah objek where the initial velocity of this object is equal to 10 meter per second. So let's say we put an external force F equal to 2 Newton on the object with the time interval of 3 milliseconds, and then the object will move and there is a change of velocity where the final velocity of the object is equal to 11 meter per second. Jadi di sini kita boleh lihat when an external force exerted on an object in the time interval delta t, so there is a change of velocity of the object. Terdapat perubahan hal laju bagi objek tersebut. Dan bila berlaku perubahan velocity of the object, therefore, there is an acceleration of the block. So, kita boleh tulis sebagai since F is equal to ma, based on this equation, we know that acceleration is the rate change of velocity A equal to delta V over delta T. So let's substitute in this equation. Therefore, we can get F is equal to m delta V over delta T. And then let's change the position of the delta T from your right side to the left side. Jadi kita akan dapat satu equation baru, iaitu F delta T equal to m delta V. Di mana F delta T is the force applied in a duration of time delta T will create impulse J on that object. So, J is equal to F delta T and M delta V, bila kita lihat, since P equal to mv, so M times the change of velocity is actually equal to the change of momentum delta P. So, daripada equation ini, ingat lagi tak? Impulse momentum theorem, kita akan kaitkan dengan dua equation of impulse, where impulse is equal to F times delta T and impulse juga adalah the change of momentum. Impulse adalah change of momentum dan impulse juga adalah force times delta T. Jadi berdasarkan dua equation ini, let's try to simplify this equation where F delta T equal to delta P. Therefore, let's rearrange the equation. You akan dapat satu equation F equal to mv minus mu over delta T, di mana F ini kita panggil sebagai impact force ataupun impulsive force. Ingat, impulsive force is equal to mv minus mu over delta T, where mv minus mu ini tadi adalah change of momentum. Therefore, kita boleh cakap that impulsive force is equal to delta P over delta T. Impulsive force is the rate change of momentum. Kerana kita bahagikan dengan perubahan masa delta T, so kita boleh panggil sebagai rate change of momentum. Sekarang kita akan lihat the relationship between impact force ataupun impulsive force dengan delta T yang kita panggil sebagai impact time. Jadi berdasarkan equation impulsive force equal to impulse over delta T, we can conclude that apabila delta T is smaller ataupun the impact time-nya kecil atau singkat, what happen to the impulsive force? The impulsive force akan jadi besar. Tetapi jika the impact time delta T semakin besar ataupun semakin panjang, semakin lama, the impact force would be decrease ataupun semakin kecil. Jom kita lihat dua contoh yang berkaitan dengan impact force dan juga impact time. The first one adalah contoh seperti ini, di mana kita ada high jumper lands on a mattress. Dan yang kedua adalah contoh di mana kita ada airbag, where this airbag will increase the amount of time for your body to stop when in an accident. Okay? Dan daripada kedua-dua contoh ini, kita boleh lihat kenapa seorang atlet lompat tinggi mendarat di atas sebuah tilam dan mengapa setiap kereta mempunyai airbag, di mana bila atlet tersebut jatuh ke atas tilam tersebut, masa pelanggaran antara badan atlet dan juga permukaan tilam akan lebih panjang dan menjadikan impulsive force between the body of the athlete and the mattress would be smaller, lebih kecil, jadi kurang rasa sakit. Sama juga seperti airbag. Okay, kenapa bila accident airbag akan keluar? Kerana airbag salah satu safety untuk increasekan the amount of time for your body to stop. Okay, pelanggaran antara badan awak dan juga airbag akan memanjangkan masa pelanggaran, so akan menghasilkan impulsive force yang lebih kecil antara badan pemandu dan juga steering kereta contohnya. Okay, boleh faham? di mana when the time of impact delta T is smaller, the impulsive force akan jadi lebih besar. Tapi bila kita panjangkan the time of impact between two object masa collision, apa jadi pada impulsive force bila delta T besar? The impulsive force akan jadi lebih kecil. Okey? Baiklah. Sekarang kita tengok formula untuk impulse. J is equal to F delta T. And let's revise again that when we have a graph of F against T, the area under FT graph will give you the value of the impulse. Okay, remember. Dan sekarang saya nak tanya awak, apakah beza antara impulse dan impulsive force? Impulse and impulsive force. So, impulse is the change of momentum, delta P. Impulse is equal to the change of momentum. So, since impulse is the change of momentum, jadi kita boleh tulis that Ft is equal to mv minus mu, di mana Ft is equal to impulse. Ft adalah impulse. So, impulse J is equal to mv minus mu. Manakala impulsive force adalah rate of change of momentum, kadar perubahan momentum. F is equal to delta P over delta T. Impulsive force is the rate of change of momentum. So, kita boleh tulis juga sebagai F equal to mv minus mu over delta T. Bagaimana pula dengan unit? SI unit bagi impulse adalah NS ataupun kita boleh tulis sebagai kg meter per second. Tapi SI unit untuk impulsive force adalah Newton. Jangan keliru ya. Jadi itu saja untuk video kali ini. Apa kata kita cuba fahamkan lagi berkenaan momentum and impulse dengan menjawab soalan contoh. Jumpa lagi. Assalamualaikum dan selamat sejahtera. Okay, so let's read the first question. Water leave a hose at a rate of 1.5 kg per second. So look at this unit. Kg is for mass and second is for time. Alright, so actually this value, the rate of 1.5 kg per second is mass over delta T. Okay, so kita keluarkan dulu maklumat yang diberi. Okay, and the speed of the water when leave a hose is equal to 20 meter per second. So, U is equal to 20 meter per second. Okay, and is aimed at the side of the car which stops it. Okay, so what is the force exerted by the water on the car? Baca soalan betul-betul. Force exerted by the water on the car means that the force from the water on the car, the direction should be to the right. Okay, so always remember that there is a force exerted by the water on the car. Okay, there is a reaction force daripada car towards the water as well. Okay, where the magnitude of the force exerted by the water on the car is equal to the force exerted by the car on the water, but in opposite direction. Okay, so now since the water will stop, so the final velocity we consider as 0 meter per second. So we want to calculate the force exerted by the water. Okay, so by the water on the car. Okay, so we will use equation Ft. So impulse is equal to Ft, remember? So impulse is equal to F delta T, and impulse also equal to the change of momentum. Okay, jangan lupa. So Ft is equal to delta P, where delta P is equal to mv minus mu. So we want to calculate the force, so it's equal to m v minus u over t. Kalau kamu lihat dekat sini, saya rearrange the equation so that I will get the unknown m over t, where m over t is equal to 1.5 kg per second. So we can substitute here, and v is equal to 0 minus u, 20 meter per second. So F, saya akan dapat negative 30 Newton. Alright? So look at here that the direction of negative is actually to the left. Okay? So this is the value of the force exerted, okay, exerted by the car on the water, which is to the left. Jadi untuk menjawab soalan force exerted by the water on car, so the answer should be in opposite direction, which is positive value. Okay, which is to the right. So this is the answer. What is the force exerted by the water on the car? Okay, so finish example number 1. So let's proceed to example number 2. Now, question number 2, we have 8 kg body moves towards the west with a momentum of 30 kg meter per second. A 20 Newton force to the east acts on the body for a period of 5 seconds. Determine the magnitude and direction of the impulse of the force. Okay, so means that here we have a body. Okay, so let's say kita ada apa-apa lah kan. Alright, so let's say we have a ball, for example, and it's moving to the west, so in this direction. And given that the initial momentum of the body is 30 kg meter per second, okay, and we have 20 Newton force which is to the east. F is equal to 20 Newton, and this external force is applied on the body at time of 5 seconds. Alright, so now question number 1. So we want to calculate, so let's write here. So impulse is equal to F delta T, and let's substitute the values. So 20 times 5, so the answer is equal to 100 Newton second. So the direction is to the east, since the answer is positive value. Okay, and number 2, the change in the momentum of the body. So remember that impulse also equal to the change of momentum of the body. Therefore, since impulse is equal to 100, so the change of momentum is equal to 100 kg meter per second. So the direction is to the east. Okay, the change of momentum. Okay, and number 3, so we want to calculate the final momentum, since delta P is equal to momentum final minus initial momentum. So we can calculate final momentum is equal to delta P plus P initial. Alright, so now let's substitute all the values. So delta P is equal to 100, and given that initial momentum is 30 kg meter per second and the direction is towards the west. So plus negative 30, okay, and then the final momentum should be 70 kg meter per second and the direction is to the east. Okay, since the value is positive. And the last one, so we want to calculate the final velocity of the body. So since P final is equal to 70 kg meter per second and equation for momentum is equal to mv, therefore final velocity of the body should be P final over m. So substitute the value of 70 over 8, so you will get 8.75 meter per second. Okay, so the value is positive value, so the direction is to the east. Okay, okay, finish example number 2. Okay, now example number 3. So here we have FT graph, and this question states that we have 2 kg object has a velocity of negative 10 meter per second at t equal to 0 seconds. So at t is equal to 0 seconds, the initial velocity is negative meter per second. Okay, and given that the mass of the object is 2 kg. So now, since we have the graph of F against T, so we can calculate the area under the graph. Since the area under the graph will give you the value of impulse. Ingat lagi ke? Okay, so saya kadakan dua color lah dekat sini. So in order to calculate the area under the graph, you boleh guna equation trapezium ataupun you nak kira asing-asing pun tiada masalah. Okay? Tapi soalan tanya apa? So the force that acts on that object is given in the graph. Okay. Calculate the velocity, the final velocity at t is equal to 5 seconds. So we want to calculate v when t is equal to 5 seconds. Alright. So what is the final velocity? Okay. So we need to write first the relationship between impulse and the change of momentum. Since kita nak cari V, kita perlukan change of momentum. Since kita ada graph, kita perlu cari impulse. Okay? So now, in 5 seconds, so the impulse of the object should be equal to delta P. So we can write that J is equal to mv minus mu. Okay? So from here, I can calculate V is equal to J plus mu over m. Okay, but we need to find first what is the value of impulse from the graph. Okay, so from the graph, okay, so we need to calculate the area under the graph. Okay, okay, so the area under the graph. So let's calculate the area 1. So it's equal to area 1 plus area 2. Okay, ni saya saja je kira asing. So area 1, 3 times 1 plus, so we have a triangle here, half times 2 times 1. So it's equal to 3 plus 1. Okay, and the impulse from the area of the graph should be 4 Newton second. Okay, so now we can substitute in this equation where V is equal to J 4 plus the mass is given 2, initial velocity is given negative 10 over the mass equal to 2. Therefore, V is equal to negative 8 meter per second. Okay, so kita dapat jawapan untuk soalan nombor 3. And then question number 4, we have Jennifer who has a mass of 50 kg. So the mass of this girl is 50 kg, is riding at 35 meter per second in her red sport car. Okay, so this is the initial velocity when she must suddenly slam on the brakes to avoid hitting a deer crossing the road. She strikes the airbag that brings her body to stop. Okay, means that V is equal to 0. Okay, in 0.5 seconds. So this is T. Okay, so question A, so we want to calculate what is the average force does the seat belt exert on her. Okay, so we can calculate by using this equation straightly, mv minus mu over T. Okay, so kita masukkanlah where m, so since V is equal to 0, so negative, so M is 50 kg, U is 35, okay, over time is 0.5. Therefore, the average force that the seat belt exert on her is equal to negative 3,500 Newton. Okay, so this is the force exerted by the seat belt on her. Okay. Okay, finish question A. And B, if Jennifer had not been wearing her seat belt and not had an airbag, okay, then the windshield should have stopped her head in 0.002 seconds. So kita nampak dekat sini, the time impact between her head and the windshield kan, jadi berkurang lah, delta T is decreasing. Okay, 0.002 seconds, sangat cepat. so that the impulsive force, okay, on her head should be besar lah. Okay, impulsive force daripada windshield ke atas kepala dia akan jadi besar dan menyebabkan kecederaan. So now let's read the question. What average force would the windshield have exerted on her? Okay, so we consider F still equal to mv minus mu over t, and this is equal to 0 because we consider Jennifer akan berhenti selepas pelanggaran. Okay, so kita just ubah saja masa So 50, 35 and t is equal to 0.002 seconds. Alright, so F is equal to negative 87500 Newton. Okay, so finish example number 4. So question number 5, here we have 8 gram bullet. So make sure you change the mass of the bullet. So I will put MBL for the bullet. So it's 0.008 kg. Please change to SI unit. And the bullet will move, okay, and strikes on a wooden block. So the initial speed is equal to 50 meter per second. Okay, so let's say we consider, so this is the diagram. So let's say this is the wooden block and this is the bullet. Okay, so the bullet will move in this direction. Okay, and the bullet undergoes uniform deceleration and stop 12 cm inside the block. Okay, so means that starting from here, so maknanya bila dia sampai dekat sini pun dia punya U pun sama lah. Okay, before dia masuk ke dalam wooden block tadi, which is 50 meter per second. Okay, and then kita consider dia akan stop dekat sini, iaitu 12 cm inside the block. In this case lah, so this is 12 cm. Okay, so now we want to calculate what is the time taken for the bullet to stop. Okay, so yeah, we can use the linear motion equation, but we don't have the deceleration. Okay, so in this case, we have two methods to solve. The first one, you can use this equation, v squared equal to u squared plus 2as. Okay, since we know that the object is moving, okay, 12 cm here. Okay, daripada starting point sampai dia berhenti tadi is 12 cm. So kita dah ada nilai s, but here we don't have a. Okay, but we can calculate a by using equation v minus u over t. Alright, so we can substitute this equation untuk gantikan a. Okay, so kalau kita buat macam tu, kita akan dapat v squared equal to u squared plus 2 v minus u over t s. Okay, so v, since the bullet will stop after 12 cm, u is 50 meter per second plus 2, v is 0 minus 50, and t kita tak tahu, kita nak cari. S, make sure you change 12 cm to meter. Okay, and then after calculation, you akan dapat t is equal to 4.8 times 10 power of negative 3 seconds. Okay, ataupun you kata tak nak guna formula ini. Jika you pernah tengok video saya sebelum ni, saya ada perkenalkan equation yang keempat, iaitu after derivation we have s equal to half u plus v times t. Okay, kita pernah jumpa equation ni. Okay, masa you sekolah pun you pernah jumpa. This equation is actually from the 3 basic equation yang you hafal, vuat, sutat, vuas. Okay, so ini equation. Jadi equation ini tiada acceleration. So when we substitute all the values, so kita akan dapat lah. Okay, kita masukkan nilai dia. Okay, kita akan dapat nilai t. So 50 plus 0 and t is equal to, jawapan dia sama juga, 4.8 times 10 power of negative 3 seconds. Okay, so ini kalau you guna equation yang keempat. And B, impulse on the block. Okay, so for B, so we want to calculate impulse on the block. So formula impulse J is equal to Ft, and another equation for impulse also equal to delta P. So in this case, since we know already the change of the velocity for the bullet, so we can use J equal to delta P. So we can write J is equal to change of momentum, momentum final, and V minus mu. Okay? So now when we try to substitute all the values, so since V is equal to 0, so kita boleh cancel je. Okay? So kita boleh dapat J is equal to negative 0.008. Okay, the mass times U is 50. Okay, so 50 we consider the bullet move to the right. So impulse that we get just now is equal to negative 0.4 Newton second. Okay, so sekarang soalan tanya the impulse on the block. So impulse on the block by the bullet. Okay, we consider impulse on the block by the bullet. Okay, kalau kita tengok gambar ni. Okay, kalau saya besarkan. Alright, so now what is the direction of impulse on the block by the bullet? So since the bullet will exert a force to the right on the block, okay, so the direction of force should be to the right, which is the force exerted by the bullet on the block. Okay, sebab kita tahu formula impulse J is equal to Ft. So if the direction of the force exerted by the bullet on the block is to the right, so impulse also to the right. But in this case, jawapan kita dapat negatif. Okay, so bila jawapan kita dapat negatif, so we consider the direction here is to the left. Okay. So, saya dah kata tadi, when there is a force exerted by the bullet on the block, akan ada satu lagi reaction force exerted by the block on the bullet. Okay, sama macam soalan air tadi. Okay, therefore, untuk menjawab soalan B ini, so we can write, therefore, okay, the impulse on the block should be to the right. Okay, impulse on the block by the bullet, ataupun kita kata impulse by the bullet on the block. Okay, yang penting on the block is positive Newton second. Okay, so the answer should be positive. Okay, so question C. Okay, question C, saya nak tulis kat mana ni? Okay, question C, we want to calculate average force experienced by the block. Okay, so average force experienced by the block maknanya pada block itulah. Okay, on the block daripada siapa? Force exerted, mestilah force exerted by the bullet. Okay, kita nak kira lah berapa force yang dirasai oleh block tersebut. That means force on the block by the bullet. Okay, so force on the block by the bullet, so we can use equation J equal to Ft. So since T kita dah kira tadi, so F kita boleh dapat. So ini adalah cerita force on the block. So force on the block should be to the right kan? So kita akan ambil positif 0.4 over the time, where the time is 4.8 times 10 power of negative 3. Okay, so kita akan dapat nilai F kita adalah positif, which is 83.33 Newton. So since the direction is positive, means that kita menjawab soalan, kita nak kira average force experienced by the block, yang dirasai oleh block tersebut. So that kita kira the impulsive force on the block by the bullet. Okay, which is to the right. Okay, so finish example number 5. So let's proceed to example number 6. Okay, example number 6, we have a ball. So given that the mass of the ball is 0.15 kg, is drop. Okay, bila perkataan drop from rest, so maknanya U dia akan 0. Okay, is drop from a rest from a height of 1.25 meter. Okay, kita kena sketch dulu. Dapat soalan, sila sketch. Okay, biasakan diri kita sketch. Okay. And bila kita baca soalan ni, apa berlaku bila ball is dropped from the certain height? So, it rebounds from the floor to reach a maximum height of 0.96 meter. Okay, so maknanya sekarang ada dua cerita. Okay, saya buat cerita part 1 dan part 2. Macam cerita komik kan? Ada part 1, part 2. Okay, kejap. Okay, so sekarang let's write here, this is part 1. And this is part 2. Okay, so part 1, when the ball is dropped from the certain height, so let's say here, okay, so U here is 0 meter per second. Ni cerita pasal free fall motion lah ni. Okay, dia jatuh ke bawah. Okay, and the height is given. Okay, sekejap. Okay, and the height is given H equal to 1.25 meter. And then what happened to the ball? It will reach the floor. Okay, and kita tak tahu masa dekat sini berapa dia punya final velocity just before the ball hit the floor. Okay, so we can calculate V by using equation from chapter 2, free fall motion. Since we have height, height kat sini adalah dia punya vertical displacement SY must be negative value because the object is moving downward, chapter 2. Okay, jadi equation apa kita nak pakai? So this is the free fall. So saya tulis dekat sini supaya awak ingat semula. Okay, so this is from projectile motion. Okay, siapa yang tak tengok video sebelum ni boleh tengok. Okay, untuk revise. So saya guna formula ini since I want to find what is Vy. Sorry, this one should be minus. Okay, 2G/SY. So this is under free fall motion. So the acceleration is under gravitational acceleration. So Vy kita nak cari, tak tahu. Uy equal to 0 minus 2. 9.81. Sy is negative 1.25 meter. So now we want to calculate Vy. So tekan calculator. So this one should be square root. So saya dapat dekat sini adalah 24.53. Okay, awak kira takut salah. Okay, so bila kita take the square root, make sure. So here we have positive, negative actually. But since the direction of the motion is downward, so the value of V here kita mesti pilih negative. Okay, so the answer is 4.95. Tapi belum lagi menjawab soalan itu baru V. Okay, because direction of negative is downward direction. Okay, alright, so now what happened? Okay, in the second part, we know already that the object is moving in this direction. So saya namakan dia sebagai U2. Because this is second part, so that's mean the initial velocity before collision. Before collision. Okay, and after collision, kita tak tahu pun berapa. Okay, kita tak tahu pun berapa. So kita letak dekat sini. So saya letak dia sebagai V2. Alright, so kita nak cari impulse. What is impulse was given to the ball by the floor. So kita nak guna equation apa untuk cari impulse? Jadi untuk cari impulse, kita nak guna formula the change of momentum. Okay, tengok sini So J equal to mv minus mu. So now V here is the velocity after collision. Okay, and this is velocity before collision. Okay, so kalau saya highlight kan, yang color kuning ini adalah before collision. Okay, yang color hijau ini adalah after collision. Okay, boleh. Tapi kita tak ada nilai velocity after collision between the floor and the ball. Tapi kita diberi maklumat that after collision, the ball rebounds and reach the maximum height. Okay, so let's say this is the maximum height. Okay, is equal to 0.96. Kecil sikit lah maximum height tu. Bawah sikit. Okay, contohnya kan sini. This is, so this is the maximum height. Contoh, okay. So, 0.96 meter. So now we need to consider the motion of the ball daripada dia dekat bawah. Saya letak ini sebagai U3. Kan, dia naik atas. Ini yang kita nak cari ni. Yang ini. Masa dia mula nak naik atas sebelum dia sampai maximum height. So at maximum height, Vy is equal to 0. So ini still under free fall. Ini kita tak tahu. So now, since the height, is equal to 0.96 meter, so we can find U3 by using equation Vy squared. So Vy equal to 0, Uy kita nak cari, inilah yang kita nak cari nanti. Tak tahu. Minus 2, 9.81, Sy must be positive since the direction of motion is upward. So positive 0.96. Therefore, kita akan dapat nilai U3 is equal to positive 4.34. Sama juga tadi kalau kita take the square root, ada positive negative. Kita akan pilih jawapan positif since the direction of motion sekarang dia tengah bergerak naik ke atas. So now kita dah dapat nilai U3 ini tadi, di mana U3 inilah U3 is equal to V2. Di mana V2 adalah velocity of the ball after collision. So bila saya dah dapat semua maklumat, saya dah dapat V2 saya, which is 4.34 meter per second, which is before collision, and U2 saya dah dapat negative 4.95 meter per second. Finally, I can find the impulse given to the ball by the floor, which is mv minus mu. Kita boleh factorizekan mass. So m 0.15, v dia berapa tadi? V2 tadilah. 4.34 minus negative 4.95. So kita akan dapat jawapan kita is positive 1.39 Newton second. So this is the impulse given to the ball by the floor, and since the value is positive, so the direction should be upward. So betul lah kan? So daripada sini, bola turun ke bawah. So bola akan exert the force from the ball to the floor, and there is the reaction force from the floor on the ball. So the direction is upward. So the answer is 1.39 Newton second. So we finished discuss all the questions. So don't forget to share and like all the videos. Boleh share dengan kawan-kawan to support the channel. So saya harap awak tidak perlu putus asa, teruskan semangat. Terima kasih kerana sudi kembali. Jumpa lagi. Assalamualaikum dan selamat sejahtera. Jumpa lagi.